I'll quickly jump onto indexes. What are indexes and why do you think indexes are important? Anyone? Can anyone tell me why indexes are important?
To retrieve the data fast.
But why do you think it retrieves the data fast?
Random access with row ID.
Row ID is a separate concept. We are not talking about it right now. We are only specifically talking about indexes. Row IDs, I'll talk in some time. What is so special about indexes that help you read the data faster?
It's a pointer to the data.
Okay.
I don't know, because the index makes sure the data is in rows and columns.
No. That's the table, right? Table makes sure data is in rows and columns.
Oh, okay.
Reading the physical blocks directly from the disk.
Kind of, but still, then the user can directly go for row ID, not for the index. Compare it with the index in a book. What happens with the index?
It makes it easy to trace the data.
Sorry, is it a?
To trace the data. What is the reference?
Kind of like. So let me explain.
Provide full table scan?
Not really. Again, that's a topic of the day. Like full table scan is good. Okay. Like so many DBAs, they accuse full table scan is bad. I don't agree with them. So both full table scan is good, full table scan is bad also. And there are scenarios you need to understand when and how. So index, okay, let me simplify it for you. When you look at a book index, you know, right? There is a lesson 1, it's on page number 3, lesson 2 is on page number 14, and so on. What is the beauty about this index? It is helping you to locate the data faster, right?
Aaron, excuse me. That question was actually asked. Somebody asked me in one of my interviews. This particular question. I just want people to know that it's a very important topic. Yeah.
Which one?
The importance of index. What
Okay.
index? Yeah. The question you just asked. Yeah. They asked me in one of my interviews.
Full table scan and index, right?
Yes. Like, what is the difference between what is an index and what does an index do? Yeah.
All right. Okay, we'll understand. So what happens is, like your book index, your Oracle index is exactly same. You need not overthink. Don't overthink. Okay. Most of the times DBAs, they are not learning new things because they are overthinking on what they know. So index is very simple, like your book, right? So if I tell you, can you locate the lesson number 5? What you will do? Do you flip through all the pages of the book? That is kind of a full table scan. Or you look at the index, okay, lesson 5 is at page number 75, and then directly go to page 75, which is faster, right? Because see, this one will always be faster. If I ask you, can you look at the word THED in the entire book and find me the pages, this becomes complex. And this is exact pure gold. And guys, pay a lot of attention over here, because I might not repeat all this stuff. This is pure gold. You as a DBA, when queries are being created, or you as a database architect, or you as a developer when writing queries for the database, make sure you kind of like address these kind of problems. If the client is saying like, hey, can you find the word THED in the entire book? See, this is a vague query. Of course, client might say anything, but understand how much resources you are putting into the. So sometimes what happens is, if client is requesting something, you try to figure out or go deep inside the requirement and understand, okay, you want to search the in the entire book, and the book is having 500 pages. Every time you run this query, I have to go through 500 pages to find out the, but can you tell me more? Why do you need this output? And that time the user might say, hey, you know what? In chapter 4, I made a mistake in the first para where instead of THE, I wrote it as THEE, right? That this is pure gold. This is exactly where real performance tuning happens. You might say like, okay, Arun, you're talking in a different world, but as an architect level, when you sit and when you work with clients, this is exactly where the problem lies. So what you do is you say, okay, so this is your problem, right? In the lesson 4, in the para 1. Okay, guys, I'm sorry, I'm using the book example because that makes life easy. So you are saying, you say like client, okay, in the lesson 4, in the para 1, you misspelled THEE, right? So rather than running a query that scans the entire book, 500 pages, let me directly go to the index, find out the lesson 4 first page. All right, the lesson 4 is on page number 20, and we all know that para 1 will always be on the first page of the lesson, right? But that's a general logic, guys. Of course, you might debate again, no, some books will write lesson 4 in one page and then start from the next page. Those all stuff we are avoiding. So we are keeping things simple. So on a general logic, we can say that, okay, the lesson 4 is on 20, the para 1 will of course be on the page number 20, right? So rather than flipping through all these 500 pages, why not I directly go to page number 20? So I rewrite my query, select star from my book where page equal to 20, because I know the user is saying they made a mistake in the lesson 4, and there and text is equal to, and this is where you mention THEE. Now tell me, is this query better or scanning the entire book is better? Of course, you would say this one is better, right? Definitely. So this is how the real tuning happens in the real world while the application is being developed. Of course, these kind of stuffs you cannot do once the application is developed. So my goal is not to tell you how tuning method happens. Our goal is to come back to index. Why indexes are important? So indexes are important because they help you locate the value. Guys, mark my words, very important. Index and row ID. I'll come to row ID in some time, but index is used to find or locate the value faster. All right, with row ID, this is very important. Locate the row faster. This is the only difference between these two. So with indexes, you locate the value faster, like exact value that you're searching. With the row ID, you locate the record as to which data block it is stored on the hard disk. And that's the beauty about the row ID. So how both of them are related, I'll talk in some time. But let's come back to the index. In the index, like we have the locate, we locate the value faster. Now coming back to employee ID index, right? We know that in the employee table, employee ID is a index column, right? We created a primary key index. So what index will store is, it will store the value in a sorted order. So what it will do is in the index, okay, so I'll create the index for you. This is how the data inside the index will look like. All right. So what it will do is employee ID 1001, and it will store the row ID, the physical location of the row, where exactly it is on the hard disk. And let's take row ID is X1 Z1 2471. I'm giving some row ID. All right. And then 1002, it will be same, and then it will be 1003, it will be same 103. Now in this case, this is how the exact index is. There are two important things in an index, guys. It will store the values in the sorted order because it's faster to find things when the data is sorted. And the second one is it will also contain your row ID. All right. So what is a row ID? It is the exact location of your physical record. And I'll show you something over here. So select star from test_1. Every table has a row ID column that is hidden, and you can't see that column until you query the column. So select row ID, comma, ID star, comma, or hash, comma, value from test_1. Can you see? These are the physical row ID. So every row will be given a unique ID number by Oracle. You don't work on row IDs, and I always say, like I always mention it, avoid row IDs usage in the application as much as possible. So what your index will do is it will store the row ID. So it's like the value or the lesson. Guys, compare it. It's very simple. Compare it with the book index. This is the lesson name. This is the page number, where exactly on the hard disk the row is stored. So now if I write a query like select star from EMP where ID equal to 1001 or 1003, all right, what will happen? As you hit enter, Oracle already knows that the columns that you are using in the where clause, that is ID number, EMP ID, one index is created. So rather than the full table scan, Oracle will use the index that has been already created. Now the beauty about index is they are sorted, so it is faster to locate the data. So it will start and then it will quickly locate the 1003. That is the lesson name that you are referring. From 1003, it will quickly jump to the row ID. That means physical storage in which block the row ID row has been stored. And it will directly go to the hard disk, pull up the block which contains the records, give the output to the user. Now, can you see how fast this is? Now, consider I'm changing this statement. Select star from EMP where name is equal to Smith. So what happens? Oracle knows that there is no index on the name column. So what will happen? Oracle has to scan your entire table to find the record where name is Smith and then give the output to the user. And this scanning of the entire table is known as full table scan. And if you see, we have already seen table access full because over here we were using a non-indexed column in the where clause. But if you move up where we have queried the database, can you see in the where clause we have used the ID column where we have a primary key, and this is where Oracle already knows that one index has been created, so it is using the index. So that's why data retrieval is faster. So that's an overview about index and row ID. And guys, don't complicate it. And like this is the simplest example. If you always get confused about indexes, try to recollect a book index and it will be easy for your life.